All right, the purpose of this lesson is to introduce you to how to use Appendix A in your textbook and some of the types of questions that we can answer using the z-distribution. Appendix A begins on page 375. I've PDF'd a column here, or a copy of the first page here. The table goes through 379, so you're going to need your textbook to answer a lot of the questions that we're going to be talking about. We're just going to talk about this first page right now. So let's take a look at this. Notice there's three columns of distinct columns of data, but within each of those three there are some headings at the top, A, B, and C, A, B, and C, A, B, and C. So in all three situations, A stands for a particular z-score, B stands for the area between the mean and that z-score, and then C is the area beyond that z-score. So the first thing I'm going to have us do is to find a z-score, and we're going to do this together, so I'll find it for us. But we're going to be talking this first time about z of 0.49. And what I want you to do on your calculator is add up column B plus column C for z equals 0.49. So what you should be calculating is 0.1879 plus 0.3121. And if you have finished that, hopefully what you got is 0.5. Okay, so let's talk about a couple of things here. Firstly, that 0.1879 tells you that there is 18.79% of the curve between the mean and z of 0.49, and that there is 31.21% of the curve beyond z equals 0.49. And then by me having you add those together, that demonstrates that 50% of the curve is over on the right-hand side of the mean. Now, let's pause for a moment. You can do that for any other z-score that you want to. You're going to get the same answer because it doesn't matter which z you choose. That which is between that z and the mean and that which is beyond the z are going to add up to 50%. Now I want you to see if you can find the table for the negative z-scores, and I'll save you some time because there is no such a thing as a table for negative z-scores because there's not any need for one. And that's because, as we will recall, the normal curve is symmetrical. So if 50% of the scores are over on the right-hand side of the mean, that implies that there are also 50% over on the left-hand side. So let me try to draw this fairly close. So if this is a z of minus 0.49, what the table tells us is that 18.79% of the scores are here, and 31.21% are here, and that if we add these up, that equals 50% of the scores. So if we add both of those 50% up, we've accounted for 100% of the scores. All right, so we're going to be using this z-table throughout at least this next section. So you're going to need to be sure that you have your book and that you can use the z-table. All right, so let's look at some of the types of problems that we can answer using the z-table. This first one, x bar is 8 and the standard deviation is 2, and the question is what percent of the scores are between the mean and x equals 5. All right, so what I've done for you is drawn the normal curve, and I'm going to use blue here. The mean is in the middle, and what is the mean of this data? 8. So where would a raw score of 5 be? It'd be somewhere over here below the mean, so right in here somewhere. And then what I'm going to suggest that you do is that you always shade in kind of what your being asked. So again, the question asks what percent of the scores are between the mean and x equals 5. So to answer this, we're going to have to transform that raw score to a z-score. And so that's what we're doing right here. So z is equal to x minus x bar divided by s. So that's 5 minus 8 divided by 2 minus 3 divided by 2 yields a z of minus 1.5. Then I go to my table and I find, am I going to find a z of minus 1.5? And the answer is no. I'm going to find z of 1.5, and I go to column B because that tells me the distance between the mean and a particular z-score. And what I find is 43.32%. Okay. And again, in the textbook, it actually shows that as 0.4332. I found that students find it easier to take that decimal over 2 spaces and make it into 43.32%. All right, so that's one type of problem that we can actually answer. Question number 2, given x bar is equal to 8 and s is equal to 2, what percent of the scores are at or above x equal 13, or a raw score of 13? And so again, I've identified the mean for you, and then you need to put the x, the raw score that we're looking for. So a raw score of 13 is somewhere over here. To me, it helps you to draw the picture and shade in so that you know you're answering the right question. Also, drawing the picture helps us recognize that this raw score of 13 is above the mean. All right, so z right here, we're going to shade. We transform that raw score to a z-score. So 13 minus 8 divided by 2 is equal to 5 divided by 2. Gives us a z of 2.5. So again, we go to our table, find z equals 2.5, and it tells us that 6.2% of the scores are at or above a raw score of 13. The last problem on this page, problem number 3, same mean, same standard deviation. What percent of the scores are between x equals 4 and x equals 10? So not surprisingly, we get to calculate actually 2 z-scores. So the z for x equals 10, and then again notice that I've then identified the score above the mean and the score below the mean. The z for x equals 10 is 10 minus 8 divided by 2, gives us a z of 1. Again, I like having a row that shows my raw scores, a row that shows my z-scores. It seems that I can kind of keep up with things a little bit easier that way. And then the z for the raw score 4 is 4 minus 8 divided by 2, gives us a z of minus 2. And so here is that z. And then I go to my table, and what I find is that 34.13% of the scores are here, 47.72% are there, and the question asks me what is the what percent of the scores are between there. And so mathematically what I need to do to find that is add those scores up. And so what I find is that 81.85% of the scores are between x equals 4 and x equals 10. All right, so let's move on to our next page and look at problem number 4. Same mean, same standard deviation. What percent of the scores are between x equals 11 and x equals 13? Again, we've identified a row for our raw scores and a row for our z-scores. The difference now is that both of the raw scores are actually above the mean. So we have to identify them, and then again I've shaded that in for you because we're looking for this area. All right. What I have to do next is identify the z-scores for each of those. So z for x equals 13 is 13 minus 8 divided by 2. So 5 divided by 2 gave me a z of 2.5. And then z for raw score 11. 11 minus 3 divided by 2 gave me a z of 1.5. So again, I go to my table and I find out that between the mean and z of 2.5 is 49.38% of the scores. And between the mean and z of 1.5, I'm going to run out of room here to write this, is 43.32%. And so the area that is shaded is what I'm actually looking for. So when I'm answering this question mathematically, I take the difference in those two scores. So I subtract. So 49.38 minus 43.32 shows that the area between those two, 6.06% of the scores are in that area. Okay. Problem number 5, same mean, same standard deviation. What percent of the scores is below x equals 6.5? So hopefully what you're seeing now is that we're using our z-scores quite extensively. So I transformed that raw score to a z-score. 6.5 minus 8 divided by 2 gave me a z of minus 0.75. Again, I'm shading here and below. Go to my table, find z equals 0.75. Look out in column C, because column C tells me the distance from that z out toward the tail, and in this case it tells me that the correct z is, or the correct amount of area is 22.66%. All right, let me move this down a little bit for us. Oops. All right, problem number 6. Same mean, same standard deviation. What percent of scores is below x equals 10.5? So we've identified the raw score of 10.5 here. We've got to transform that into a z-score. 10.5 minus 8 divided by 2 is equal to 1.25. So I didn't write that down on there, so I'll do it right now. 1.25. And I go to the table. The table says the distance between the mean and a particular z, in this case 1.25, is 39.44%. And then I have to use my old canoodle and recall that over on the whole left-hand side is 50% of the scores. So 39.44 plus 50 says that 89.44 of the scores were 10.5 or below. As a little key to the future, that's actually how we're going to find some percentile scores in the next lesson. So don't worry about that now, but that is how we're going to find percentile scores here pretty shortly. And then I've got 2 more problems in this section. Problems 7 and 8. So let's take a look at these. Same mean, same standard deviation. This is a little bit different type of question because it asks what raw score marks the point in the distribution at which 10% of the scores fall below it. So what we've identified for us here is the lower, we're looking for the lower 10% of the scores. And how did I know that it was over on the left-hand side? Because I know that from here over to here is 50% of the score, so the bottom 10% is in this far lower tail. All right, so follow along with me. What you're going to have to do is first find the z whose area is as close to 10% as possible. So you've got to go into the table, out to column C, and find the z in column, and you're looking in column C, and then you're going to go out to the A column. But looking in column C, what is the z score associated with 10% of the scores, or an area of 10%? And what you're going to find is that z is on the table 1.28. Now, why did I have a negative 1.28? Because I know I am on the left-hand side of the distribution, and I know that any z's over on this side are all going to be negative. And that's really important, because if you forgot that and let that be a positive z, you'd actually end up getting the wrong answer. So what I'm really looking for is what raw score is right there. All right? So go into the z table. You're looking in column C. You're looking for the number that is as close as possible to 10%. Now, as I recall, there are a couple of numbers that 10% is between, and what I really literally want you doing is finding the one that is the closest units to 10%. So for this example, that number is going to be minus 1.28. All right? And again, what we're looking for is a raw score. So I set my z equal to x, because that's my unknown, minus 8 plus 2, or excuse me, divided by 2. So again, I set my z equal to, so minus 1.28 is equal to x, that's my unknown, minus the mean divided by the standard deviation, which is 2. Multiply, take that 2 across, so minus 2.56 is equal to x minus 8. Add 8 to the left-hand side, and so what I find is that the raw score that marks this point in the distribution is 5.44, raw score 5.44. And I can check that. It should make sense, because my mean, I'm right over my x-bar, my mean is 8. It would make sense that the answer to this question, because I'm on the left-hand side, should be something lower than the mean. And so I can feel pretty sure that I'm correct, because 5.44 is below the mean. And then the last type of question that we can answer using this z distribution is if we know how many folks we were dealing with. So in this case, we're going to use problem 3. If n equals 500, how many people scored between x equals 4 and x equals 10? And let me clean this up a little bit for us here. All right. And so in problem 3, we found that 81.85% of the people scored between x equals 4 and x equals 10. Now we're actually answering the question, well, how many people of that is that if we have 500 people? So I set 0.8185 times 500, and the answer is 400 people. And unless someone in here wants to be a volunteer and be that decimal of a person, what we're always going to do is just round down to the lower number. So in this case, and I can't remember exactly what the math was, but it was like 409.25, let's say. And so we're going to say that that was 409 people. All right, so you've got a handful of types of questions that you can do using the z-distribution. Make sure when you start doing this you have your textbook, because you're going to need all of the pages of the Appendix A. And have fun doing those practice problems.